Hi, good afternoon, everyone. Hello. Can you hear me? Can you hear me? Oh, fantastic. Yes, good, good. Thank you. All right. Today will be the last. Yeah, today will be the last lecture. We're gonna have a review uh, uh, for for summarizing what we learned this semester and have a outlook for the preparation of final exam. Next week will be the project presentation. So today we need to come up with some arrangement for next week presentation. And yeah, and the problem, I receive a number of questions coming from you guys. See, how about the video, the project a presentation of the video? So, all right. So what do we do with that? So I want to hear the suggestions from you. See, how do we deal with the video recording for the project demo? Because it's sometimes it's just impossible to record the video separately because we work from home, and so there are some real challenges to make this video. So what do you think about the video? Someone, yeah, you just unmute yourself and speak if you would like to inject with your comments, please. So how do we deal with the video and the final project presentation? Project presentation, I believe, is fun. You can share your desktop, share your screen, share your slides, and we can make presentations in the same way as we have a class. But for the video recording, what do you want? Do we want to completely remove the requirement for videos? Be fair for everyone. So video recording is not required for the short demo, 2 minutes video, or we still want to keep that. What do you think?
I think we should keep it. I think it's a really good way to show off, what your team has built, and even if you couldn't complete all of your, the requirements you had set out to complete in the beginning because of the quarantine and social distancing, I still think it's a good way to showcase what you built.
Thank you, thank you. That's that's comments. Good comment. Yeah, we keep the video. But how about the challenges? Well, some people they have challenges of record the video and well, probably I guess there are some kind of copy and editing for the video and upload it online on YouTube. What else do you think? Anyone?
So my question would be, if we're doing the report, would we have to present or do a video about our project, or how would that work?
Originally, we said, well, we have a 2 minutes of a short video, like some kind of a thing you would like to show off to the rest of the world. A short 2 minutes video, like either demo or commercial, however you want to cast this video. For the presentation of the project, we still keep the presentation, like group 1 to 6 will present on Monday, and groups, let me share my desktop, my screen. See, here is can you see my screen? Yeah, the groups, first 6 groups will present on Monday, and each group roughly, let's see, around 8 minutes for presentation, and 3 or 4 minutes for QA. Let's see, 3 minutes, and 1 or 2 minutes for transition to next groups. So yeah, the presentation itself is doable. But yeah, do you want to include the video in the presentation or not? I will leave it. I will leave this up to you. And I would like to get your comments or feedback on that. To get the video done, how difficult it is, or you think it's completely not a problem. All right. So the video is part of the Sumi said the video is part of the presentation, which is also fun. Yeah, which is also fun. The challenge we are discussing here is some people might have a difficulty to make this video because 3 or 4 people, they work separately. So probably one person need to make the video or the other contribute. So how do we deal with this? Or do we want to keep the video optional, or do we still want to keep the video as required? Since the beginning, we said video is required.
I think the video should be optional, just in case some teams' projects can't, be done, or video can't be made, unless multiple members of the group are there. So I think that'd make it more easy for groups to work with what we have.
Okay, optional. Okay.
I know the other option to doing, you either do implementation or a research, and I know the research people have to do 5 to 8 page reports.
Right.
So maybe instead of a video, they can do maybe a 3 to 5 page report, something smaller, because implementation is different. But I feel like if you remove the video, it's very unfair to the research people who have to write 8 pages.
Right. Exactly. I think that's a good point. For the research people who are submitting paper, there's no impact to those people. Right? But for those who work on the implementation, I understand there are some challenges. Yeah, you can't work together, and there are some changes to the project. So if how about this? We see a video is, well, either you submit the video as planned, or you submit a longer report, like the 5 pages report, instead of submitting a video. How would that be reasonable for everyone? The challenge, another challenge comes right now here. Yeah, Travis. Yeah, that's good point. Good point. See, writing a report, long report, within a week is challenging, and especially right. Some people have left. Right. That's a good point. So that's a challenge.
Professor, I just had a question. When you did the video, were you asking for everyone to be speaking in that video, or could you have it as one person speaks but everyone else collaborates on the video idea?
I would say, just one person is enough in this situation. It's not possible to have everyone. No, it's just hard. You have to do copy editing, but one person is enough on behalf of the whole project to make this video. Would that be easier for everyone to make the video, or?
I feel like it would kind of give the option for groups who may not all be together, that maybe one person kind of writes up what they want to do, one person records it, and then another person edits it. That way people still do that group collaboration, but with that way, even if you're remote, you can still work together.
Good point. Thank you, Sammy. Who else? A good idea. I think that's a good idea. Still keep the video, but one person can make it.
I had one more question.
Yes.
With the video, do you still have to do a presentation and then have the video in there, or can we just do a video and show that?
Let's see, the presentation is still a presentation. You have to make a slice, and the video can be part of the presentation. Let's see, 8 minutes of your presentation. Maybe video can take 2 minutes, and the rest 6 minutes will be the talks from your group members. Anyone else has any suggestions or challenges? Some people, some groups also already reported, they cannot finish whatever they promised in the beginning of the semester. I understand, that's no problem. I told I told them. No, I tell everyone you can make any reasonable adjustment due to this COVID-19 as a good reason. See, you have to adjust the scope of work. You have to adjust the progress, or next week you're gonna come up, but at least you come up with a conclusion. The conclusion is required. A conclusion of your study. All right, and any other suggestion with the video in the project? So if not, let's finalize this the format. See, each group should present a short talk around 8 minutes, and including the video. And the video can come from one person only. And the talk, ideally, a talk come from all the group members. But some group members might have challenges. They might be out of town. They might be internationally somewhere. So it's not required to have everyone on board during the presentation, but at least one person in one group need to be here online next week to present the work on the behalf of everyone of that group. How's that? Good. All right. That sounds reasonable, and let's stick with the plan. And for the due date, for the short one-page report, if you're doing implementation, or the long paper, if you're doing research paper, the due date, let's see, how about next Wednesday? Next Wednesday is we're gonna finish all the presentation. So the next Wednesday is also the due date of the short one-page summary, or the 5 or 8 pages paper. Would that be good? Sounds good, right? Okay. All right. All right, what else for the project? Wait, we have to do the video and the paper? No, no, video and the paper. If you're doing implementation, you need to do the video. If you're doing research, you only need to do paper. Paper, the research, you don't need to show video. You have nothing to show in the video, right? The research paper is the product. But if you're doing implementation, you need the video, and also you need just one page of summary. The one page of summary includes a short paragraph, we call abstract, and a picture of your product. Maybe if you're Arduino, Raspberry Pi, something you could take a picture, or it's a software, you take a screen catch or screenshot of the software, and then the link of the YouTube video you just made, and that's it. That's the one page of summary. We call it a one-page summary report, but this is not a paper. The paper is much longer, either 5 or 8 pages. All right, so hopefully that's clear, and then we can move on to the review session of the class, and some outlooks and discussion of the pivoting point of the final exam for preparations. For research paper, is there still a presentation? Yes, for research paper, for those groups who are working on research paper, yes, you're still making a presentation, but you're not going to make a video. It's a presentation. It's like you go to conference, we publish paper, right? We need to present. In addition to the paper, also present to the audience, see what did we do and why do we do that? What's our contribution? So, and take questions from the audience. That's the format for the presentation for the paper. All right, let me double check. The groups, I remember we have one group, a graduate student group, work on the paper. For the other people, all the other people working on the implementation, right? Am I right? So if that's still the case, then if you do implementation, you need to make a video, unless some people change their project, well, from the implementation to the to a paper. If that's the case, then you need to submit a paper, but still there's a presentation required. I don't think there's any group switched from implementation to paper due to the COVID-19. Before the school closure, we already started with the presentation. We started our work, right? I believe 11 groups are working on the implementation, and only 1 group of graduate students work on the research paper. So, all right. Okay. All right. Let's see the review. All right. Can you see my slides?
Yep.
Okay, thank you. So, yeah, this is recorded. Yeah, feel free to take notes, but this is recorded. It will be posted online on Blackboard. All right, for the review, for the final exam. Oops. So first, let's see the knowledge, right? And then we'll see the exam. Knowledge is what we learned in this semester. We classify it in 4 categories: the basic wireless signal propagation and the Wi-Fi, our most widely used wireless technology, and WiMAX LTE. That's a different type of popular technology. And last but not least, IoT, Internet of Things, is dominating the industry. So that's the 4 essential part we studied in this semester. And this is the wireless signal propagations and basic wireless protocols. We summarized the mainstream wireless protocols with several technologies and standard. For every protocol you use, there is a corresponding standard defined by a documentation of IEEE 802 or 802 dot something, right? And some popular standard like 802.3, which is Ethernet. Still we're using that. 802.5 token ring. We stopped using that, but still this famous protocol. 802.11 Wi-Fi. We are using that, and we will use that extensively in future. And 802.15, the family of the Bluetooth, Zigbee, and visible light communications, right? Bluetooth .1, Zigbee .4, and .7. There's a new family member .7, 802.15.7, called VLC, visible light communication, which is going to be the candidate for the next generation in year 2030. 10 years later, the light will be the candidate for the wireless signal. All right, WiMAX 802.16, and the WiMAX is very much similar to LTE, long-term evolution. And this is how your phone works. TDMA-based, time division multiple access-based technologies, right? TDMA plus OFDM, orthogonal frequency division, multiplex. Sometimes OFDM, multiple access, right? A means access, medium access, right? So that's the foundation of modern wireless technologies. See in the final exam, see, hey, 802.16 LTE, they are based on TDMA plus OFDMA. That should be correct. If I see, hey, 802.16 plus LTE, well, they are based on CSMA, CA, right? That's wrong, right? CSMA is Wi-Fi's family of the medium access technologies, but WiMAX is more like TDMA plus OFDMA. TDMA is like MAC layer, time division multiple access. OFDM more like physical layer, right? Multiple small parallel channels, right? That's a technology to use. And 802.21, we didn't spend too much time, but we just mentioned that media independent handoff. MIH, media independent handoff. You can switch from one base station serving with Wi-Fi to another base station serving with LTE, which nowadays is very common, but still keeps the conversation going on as a hot, not cold, as a hot conversation, hot handoff, or soft handoff, not a hard or cold handoff. Right? So media independent handoff. You can do handover or handoff, regardless of media. That's a protocol. AU2022 called the Wireless Regional Area Network, WRAN, itself doesn't carry too much information. The concept is called cognitive radio. Cognitive radio, smart radio, right? You borrow the channel from others, but you don't, you minimize, or in fact, you don't interfere, you don't impact the other users' usage of their spectrum. If they need to use their spectrum, you have to give up and return the spectrum to them. But that's kind of mechanism to borrow the unused white space spectrums, which can boost our channel capacity. That's technology. And smart grid and vertical integration of IoT, that's a kind of the one of the latest, most recent standard. Smart grid for power grid using Internet of Things. All right, that's the brief history in wireless computer network protocols. And we introduced the medium access control. Medium access control is actually the key for this class, right, on the Mac layer. A basic medium access control, frequency division multiple access or time division multiple access. That's the two simplest approaches. The first generation of wireless use TDMA, FDMA, frequency division, right? Each user has its own dedicated channel, and the second generation 2G and so forth start to use TDMA, time division multiple access. Different users have a different time slot, and they're tied to use the channel. All right, and signals transmission. Well, signals, there are two types of signal, two types of data. So analog signal, analog and digital in combination with 4 combinations. So all analog, like telephone, early stage telephone. Nowadays, we don't use this all analog system. Not much, not much. But modern, we still use a lot. There are a certain medium, like the wireless, like the open space. Wireless naturally takes natural media, the nature, actually the open space nature takes the analog signal, but our data in our computer, that's computer, your screen, your desktop, your laptop, your phone, our computer deal with the digital data. So we need a special device called a modem to do the translation, to do the modulation, to do the modulate from digital to analog, right? Like BPSK, the PSK, QPSK. Right? Modulation model, modulate and demodulate your signal. And from analog, the physical world, our real physical world, analog signal to digital signal, right? Analog data, right? That's kind of, for example, the physical world, that's a camera. You have a camera, take pictures, or the microphone take the voice and convert to data signal, and computer can use it, utilize. But the most of the nowadays modern devices and system in network is all digital, all digital. And data transmitter, remember repeater can clean and generate a clean version of signal and remove the noise and interference at this stage. So the noise and interference will not be cascaded and will not be boosted or amplified. Analog signal, on the other side, you can't. The analog signal cannot remove the noise and interference, but repeaters can, as a relay, they can do that. But they introduce more delay or latency, more time. The more relays you have, the more delays, because you have to decode and forward data, right? And the delay eventually impacts the TCP throughput. And in one of your quiz and one of the homework question, we deal with that, right? TCP 1/n. N is number of hops, right? The more number of hops, the lower the TCP throughput. All right, and the coverage of the distance in wireless is number one challenge. Longer distance require you have a higher transmission power, require you to have a lower frequency, right? Assuming all other factors are the same, or you can have a better design of a receiver circuit or receiver algorithms to tolerate more errors, or you can use better or more expensive receivers, which is more sensitive, with higher sensitivity to pick up signal, weak signal from the air. That's another approach. Or you can use better, a huge antenna, specialized redesigned antenna to convert your signal to a certain direction, like this antenna, right? So there are many, many approaches to improve the distance or D. And if you have antennas in the model, you consider here, receiver antenna and transmitter antenna will both the signal, right? Boost the signal. And that's the very famous free space pass loss antenna, pass loss signal strength model. In general, the ideal case, you double the distance, signal become a quarter. In real world, in urban scenarios, like D to the fourth, right? You double the distance, signal become 1/16 in downtown scenarios. In rural area, remember I showed you the testing case, D2.8, right? D2.8 in very rural area. Right? So D2 square is ideal. That's outer space. All right, and the wireless class in this wireless 596, where we discuss MAC layer and FIT layer, and we only focus on the lower two layers in this class. That's 596. Although we mentioned higher layers, but we didn't discuss the details. We have a focus on lower two layer. It doesn't mean the high layer are not important, right? The high layers, we assume high layer, we use IP. The transport, we use TCP. Some occasional case is UDP, but most likely TCP. And the session layer, presentation layer, we didn't discuss much details, right? But application, like you have a number of choices, like HTTP, right? As the most widely used protocol. But again, these are the issues we discussed in another class, 576, a computer network. But 596 is lower two layers. We really deal with the low-level details, the dirty details of the wireless networks. And a lot of things we need to take care, like bit level, and the packet level, right? That's something we discussed, right? Physical layer, signal propagation. We have a lot of discussion on that. And the error control at link layer, medium access, error control, channel coding, and retry. These are two different approaches. Channel coding, sometimes we call FEC, forward error correction. Forward error correction. The actual forward error correction algorithm is not required, or the algorithm are not required in this class, right? If you go to graduate school later, in different classes, they might talk about that, but in this class, the conclusion is, well, if you want to reduce the bit error rate, well, you need more FEC redundancy. That's a general trade-off. You know that, that's enough. Retry called ARQ. The more retry you have, the higher reliability you have, the lower packet error rate you have. And exactly how much is the packet error rate by adding more retries, you know that. There is a homework question. So we have a higher requirement for the ARQ understanding. Lower requirement for the FEC. And medium access control, we focus on CSMA. CA. CSMA, CA, that's a medium access control. Right? And we also discuss TDMA, time division multiple access, because TDMA is easier. It's easier to understand. Right? We heavily focus on CSMA, which is Wi-Fi based medium access control. All right? And then we start from Wi-Fi. The simplest Wi-Fi is 802.11b version, B version, introduced in 1999, 20 years ago. And it defined two devices, type of devices. One is the wireless station, or sometimes called client, sometimes called mobile, and the AP access point, sometimes called base station. And Wi-Fi support, since the beginning, since it's born, it supports two modes. Infrastructure mode, which is heavily used nowadays with the access point, or ad hoc mode, which you don't need access point to establish the network. But we heavily focus on the infrastructure mode. And you might have an extended distribution system with multiple APs serving the same network. And then we started the evolution of Wi-Fi from very beginning. Their medium access control didn't change. Right? although they're choice factors, their capacity, signals, resources, a lot of things changes, but their soul doesn't. Right? All right. So the Wi-Fi use CSMAC. In short, CSMAC means carrier sense multiple access with collision avoidance. And we also discussed CD, collision detection, which is being used in Ethernet. And what does CSMACA do? We use a figure to explain that, right? And if the channel is clear and you have something to send, some frame to send, you send, right? After waiting for DIFS, short period of time, distributed interframe space, right? Short piece of time. And SIF, short interframe space, even shorter piece of time, right? The ACK is given, acknowledgement is given from destination. And then all the others, if you have data to send, you have to wait until the channel is clear. It means the ACK is finished. And also, additionally, you wait DIFS and then start a random backoff. This is a random backoff period determined by the random number you generated locally. And whoever generates the smallest random number, who gonna be the lucky one to send the frame in the next moment. All right. So that's the backoff. We call backoff approach. Using the random number to avoid collision in Wi-Fi. All right. And we also introduced the AMC, dynamic rate or rate scaling. And we also need to know some benchmark data of each Wi-Fi technologies, like the basic data rate, and why they achieve that data rate. Right? For example, AC, the Wi-Fi standard we are using nowadays, most likely using in our residence, right? Compared with the previous generation, what was the improvement? Yeah, more bandwidth. In general, in wireless network, if you would like to have a higher throughput, the easiest way is to have more bandwidth, more spectrum. Started from 40 to 160 megahertz or millions of hertz. You are four times of the spectrum you use compared with previous generation. So that's significant. Right? And constellation, vertical bar, constellation. You're putting more bit per symbol. Right? Your 11N, you use 64 QAM, and now you're able to support 256 QAM. And you should know how many bits do we put to each symbol for 256. So 2 to the something to equal to 256. That's the number of bits you put to each symbol. And here 64, 2 to something is 64. And that something is also number of bits. Right? That's 6, that's 8. Right? That's the improvement in different dimension. And the third dimension is antennas. Right? Instead of using 4 antennas, now you're using 8 antennas. Of course, it's more expensive, but you have more parallelism and you have more redundancy. Redundancy here means good, right? If one flow is wrong, the other flow might help to recover data. So that's the 3 major approaches why nowadays Wi-Fi improve the capacity of the wireless channel. All right, and we formally introduce the modulation, and we use this BPSK as a baseline, the most robust, but the least efficient. QPSK, 16 QAM, 64 QAM, and we also mentioned 256 QAM, right? Which have been already used in the A211 AC, right? AC, the current and future, 1024 QAM, and maybe, right? Maybe in next some years, right? 1496 QAM. The constellation. This is a constellation because it can be very busy, very dense. All right. we need to know what's the pros cons. If you go from the BPSK to all the way to 4096 QAM, what did you get? What did you pay? What you get, of course, you have much higher throughput, right? BPSK, you can only send 1 bit per symbol. And 4096, how many bits you can send per symbol? How many bits you can send per symbol? 14? Is that right? So 14 times. 14 times of the capacity, right? So the difference is the distance between the neighboring stars in the constellation is shorter. So easily, the same amount of noise or interference gonna mess up. And for the BPSK, it's very hard to mess up, right? Mess up between 0 and 1. Here it's very easy to mess up. Once you mess up 2 stars, you mess up a number of bits, not only a single bit, many bits. The number bit you put to 1 symbol. Once you mess up a whole symbol. All right, that's a trade-off. And the trade-off also is in the distance. Higher data rate because you use denser modulated scales. They are weaker against the noise. They require higher signal strength, higher signal to noise ratio. So you can only cover short distances for high speed. But low speed can cover larger distances, right? Like QPSK or even BPSK here. Even longer, right? So that's another trade-off, another way to see the trade-off between distance and throughput. And we also introduced OFDM, orthogonal frequency division multiplexing. And this is the foundation of nowadays physical layer wireless networks. Right? For the whole channel, a huge channel, you divide this huge channel into multiple small parallel channels. And each parallel channel, each small channel is modulated, is carried by a sync wave function. And this wave function has no interference to all the neighbors because they cross with zeros at fixed cycle. And that's exactly the center frequency of the neighbors. And each channel, sub-channel, let's see, can be individually modulated. You can choose different modulated scales. Depends on how noisy this channel is. This channel is very noisy. You might want to use BPSK. This channel may be very good. You can use 16 QAM or even higher, 64 QAM. So this provides you a lot of flexibility, and it's very strong against the multipass effect. And we discussed a lot of other stuff like frequencies, right, for Wi-Fi. Wi-Fi started from 2.4 gigahertz, but Wi-Fi also supports 5 gigahertz range. Right? And even nowadays, you have 2 gigahertz, 2.4 gigahertz, 5 gigahertz. Right? As most of the AP access point, most of them support to the configuration. Yeah, you can do configuration separately from 2G and 5G devices. All right, but they are not compatible. If your AP support both 2G and 5G, it means they have 2 sets of radio, concurrent and serving you. All right, and mobility introduced more challenges like Doppler effect. And the Doppler effect means what the perceived signal strength, signal frequency changes due to the motion, or due to relative motion between the sender and receiver. So, in short, the change of the frequency cause problem, and the change of frequency, you perceive the frequency to be higher than normal. If target is moving towards you or target is moving away from you, the frequency is perceived as lower than it should be. And that's a Doppler shift. And Doppler shift can also be used in radar gun or the weather forecasting. All right, WiMAX and LTE. WiMAX, as we discussed, is to provide a larger coverage for city scale. You can deploy WiMAX on top of the roofs of the buildings and cover whole town easily. without deploying fiber cables underground. Sometimes it costs too much. Right? So WiMAX is kind of wireless broadband access. But WiMAX fundamentally different from Wi-Fi. WiMAX has a queue concept, a connection concept. So different services have different connections, like email service, like web service, like the video services. And WiMAX also use TDMA-based approach, time division multiplexers. So each frame, like 20 milliseconds, or for LTE, your full network, 10 milliseconds, right? 10 milliseconds. It's a fixed cycle. And each cycle, each frame is divided into downlink and uplink. And their ARQ is a special type ARQ, right? Because select and repeat with a bitmap. If you lose some packet is indicated. So next round, you only need to send, this should be packet 1. You only need to send 1 packet. The missing packet is very efficient. And the packet transit in the air should be buffered temporarily unless you receive acknowledgement, the ACK. Then the packet can be removed from buffer. Otherwise, you have to assume the packet is lost, maybe lost. You have to retransmit it. And WiMAX and LTE frame structures are very similar. Right? So the fixed cycle, 10 milliseconds. You have downlink, uplink, and downlink as a special, very special frame burst. 2 map, 2 CDs. What are the functionalities of that? Well, that's also part of the question in a true or false question in the midterm exam. Time is included in the map. The modulation coding is included in the CD, a channel descriptor. So map tell you when, and CD tell you how. All right. So the map serves as somehow like a TV program guide. Tell you ahead of time what should start, when you should grab the data, when you should push your data, right? Or send a receive or send. Right? And CD tell you how, what modulation you should use to send data or receive data, what coding mechanism should you use to send or receive data. Now that's need to be agreed between receiver and the transmitter before data conversations going on. All right. And the ARQ has impact of packet error rate. Without the ARQ, that's a normal packet error rate. Based on bit error rate and packet size in bit, you can have the packet error rate estimation. But with the ARQ, consider retries. Nmax retries, the error rate is the Nmax plus 1. PR to the Nmax plus 1. Nmax means the number of retries. 1 means the first attempt. And the proof here is not required, but the conclusion is required. Conclusion. There is a homework question regarding this. And also the average number of retries. Right? The conclusion is it's useful. The actual proof is not required. So if you apply Nmax retries, what's the average transmission you're going to expect? This is not integer. It's just a kind of real number. All right. And because we have this average number of retransmission, so when we estimate the bandwidth cost, the bandwidth consumption, this is a source traffic, the amount of a pure payload you're going to generate, multiplies by the actual retransmission, transmission plus retransmission. That is the total bandwidth consumption. This is the data. This is the network. All right, and for the IoT, energy efficiency, energy becomes the key of the discussion in the last part of the class, right? So where does the energy goes, right? Sensing and CPU consume very little energy, but transmission, radio transmission consume most. Receiving consume the next. But idle listening consumes as much as the receiver receiving energy. Which means if you turn your radio on, regardless you have data or you have no data coming to your radio, you consume almost the same amount of energy. So the guideline is to turn the video off to sleep mode if you know you have no data to receive, right? You know you have no reason to turn the video on. So that's the philosophy to save energy by reducing the idle listening. But you cannot always just simply turn the video off and on. But it depends on many factors. The energy in radio consumptions, right, have two parts. One part is the circuit consumption, usually it's linear. The other part is the amplifier, RF amplifier, which is nonlinear. So total energy consumption is the summation of both circuit and amplifier, two parts. And this is actually amplifier energy consumption and circuit energy consumption is impacted by the communication range. Long range, short range communication, they have different behaviors, different consumptions. All right, so we dig into details for the amplifier energy consumption. For transmission time or transmission data rate, longer transmission time means lower data rate or slow. Shorter transmission means fast, higher data rate, fast. From slow to fast to slow, right? From fast to slow. The energy consumption for amplifier reduce a lot, non-linearly. But from fast to slow, from fast means high data rate. Slow means low data rate, right? Longer time, low data rate. From fast to slow, the circuit energy increase linearly because more simply you turn the radio on, turn the circuit on for a longer period of time. So overall energy consumption is a plus from the non-linear and the linear. So it goes down non-linearly and goes up linearly. And that is a curve, which is we call convex curve. Convex curve has the lowest point. This lowest point means the most energy efficient operating point. This is the transmission time or data rate, transmission speed. What is the best transmission data rate you should choose? You transmit slowly, fastly, or somewhere in the middle? That's a homework question regarding that. Also, for short range, long range, short range, medium range, like the RF portion of RF in the percentage of RF energy is different. Right? So long range, RF consume the most. Medium range are still the most, but comparable to the circuit. And low range, circuit consume more energy than RF because you don't need to boost your signal. That's a distance related issue. Like you run half marathon, you certainly don't want to run with the highest speed, right? So for such long range, maybe you want to use a low data rate. Short range, you might want to run as fast as possible and sleep. That's using burst and sleep. All right, and relay. For relay, it's just a beautiful technology to extend the coverage, right? If you use no relay, a single base station, single AP coverage is like this. You cover, this amount of the coverage. But if we deploy a relay at 100 meters, the relay is going to extend the coverage a great deal. So this amount is the gain of relay. 2 relays here, 3 relays here, and 4 and 5. But relay also introduce the cost. The cost is the peak rate from 42 to 21, from 21 to around 14, right? From 14 to around 10.5, around 10, right? So if I deploy another relay at here, 400 meters, what is the peak rate? What is peak rate? Think about it. That's the consequences of relay and why it introduced, because relay introduced more time, more latency. All right. And also we have problems of the IoT. We said our IoT RTS CTS is nice technology to avoid the hidden terminal problem, right? Hidden terminal. A and C are hiding from each other. That's called hidden terminal. Hidden terminal problem. Because A and C cannot see each other. If the A and C both send data to B, collision happens. The RTS CTS is designed to avoid hidden terminal problem, to block the two hop neighbors. But it may be too restrictive. It introduces an exposed terminal problem, like the B and A for this communication. Concurrently, C and D cannot have this communication because A and B has this communication. This is called exposed terminal problem because C is blocked by the CTS. In fact, C and D can send data while A and B or B and A is sending data. That's no problem. But unfortunately, although A and D are so far from each other, they are muting each other. All right, that's the exposed terminal problem. All right, questions? Chat room. All right, questions? Is a final paper, a final exam, all-inclusive, only second half? Obviously, all-inclusive. Final is cumulative. In fact, the first half of the semester is very important. This is a foundation. It's a foundation. The second part is more like a higher level system. Right? First, it's more fundamental. So let's make it clear. It's a cumulative. It's all-inclusive. All right. If you have no further questions, let's take a overview of the final exam. Final exam is 2 weeks later. 2 weeks later, according to our timeline. Monday, May 11th, right? 1 to 3. Online. All right, let's still keep this time, right? Keep the time. Right. So another question. So it sounds like we are better off starting midterm material versus content from after. I would say no. Well, midterm exam, of course, yes, but we have additional content. So I would say the best resource is homework. The second best resource is a midterm exam, right? And slides, of course, slides is on top of everything. Slides is number 0, homework number 1, midterm number 2, and all the others number 3. If you want to prioritize the study, right? All right. So what else for the? I'll stop sharing my screen. All right. The final exam is like 2 hours. 2 hours. We'll have 7 questions. 7 questions. First question: true or false? True or false? 15%. True or false? 15%. And true or false literally come from everywhere, right? Anywhere. I believe the true or false questions. You'd better study from the slides. Slides, they are really broad, And well, of course, each question either true or false. There's no third answer, right? Either true or false. No ambiguity. So 50% chance you make it right, 50% chance you make it wrong. Yeah, 15%. All right. Second question. Oh, before I move on, I see some questions coming from the chat room, chat window. Will 2 hours be enough for us to finish? 2 hours, I believe, is enough because it's open book. Open book. You should be busy. The exam is designed. See, you have 2 hours, and you have all the resources you can use, right? But you'll be very busy, very busy. That you have no time to talk to each other. So yeah, let's finish the exam individually, right? But you could be very busy, I'm sure, yeah. But you can finish that. 2 hours is just enough, just about the right time. You finish everything. Firefox and Google Chromes. Yeah, try to use different. Try to have more than one browsers in case one doesn't work, right? But yeah, my exam will be PDF file. I expect you to give a PDF file back, a single PDF file back, similar to what you did in the midterm exam. In midterm exam, we had some issues. Some students sent it non-PDF version. Finally, we had some difficulty to open that. Eventually, we solved the problem. But I really appreciate just single PDF make your life easier, my life easier. And you feel free to write, use the handwriting on paper and take pictures and insert pictures to the Word file and save it to PDF or scan, however you want. Yeah, however you want. All right, any other questions regarding the exam format? It could be very similar to the midterm exam, but this time I'm not going to give a answer sheet. You can use whatever answer sheet you have. Like you just write on a piece of white paper and take pictures or scan it. It doesn't matter. Just feel free to use whatever the format. All right, that's the first question, true or false, 15%. And second question, calculation, 5%. Third question, calculation, computation, 15%. 15%. You have 3 sub-questions. Some question come from audience. Are there a lot of math problems? There are similar to the homework questions. Similar to the homework or the midterm exam. Yes, yes. Question 3, 15%. Question 4, 15%. 15%. Question 5, 10%. Question 6, 15%. And question 7, 25%. 25%, which means you have several sub-questions, several sub-questions. So all these questions, all the questions are OC, safely speaking. Most of the questions are coming from the homeworks, Because the homeworks the most fundamental series of the wireless, right? So if you understand the homework, do the homework by yourself, you understand how you come up with these numbers, and I believe you understand the fundamentals of wireless. Yeah. Can I upload the answer sheet of a homework? Yes, of course. Once the TA finish grading the homework 4 and the homework 4 answer solution will be posted online. And yeah, next week, sometime next week. All right, that's the 100%. And there is there is homework 3 and homework 4 need to be posted. Okay, homework 3 and homework 4 will be posted online. Yeah, soon, very soon. I'm waiting for some late submission for homework 4 because well, some people are still might still possibly have a late submission. I don't want to release the answer before their submission, but yeah, next week I'll do so. Yeah, next week homework 3, homework 4 solutions will be online. All right, that's the 100% of the final, and the bonus. There is a 10% bonus for the final. 10% bonus is also a question number 8. And the format is give you a story, and the story is some story you have seen already in the class. I can't tell you when. I don't remember exactly when I told the story, but more than once, for sure, more than once. The story, and you answer the questions, short questions, briefly. 10%, right? 10%. All right, this 10% is on top of this 100%. So theoretically, for example, some people can achieve that. If you already achieve 100% right, correct in your final exam, and you also did this 10% right, you're gonna have 110% out of the final, which means the final is 30% of the total. So you're gonna have a 33%, 33 point instead of 30. So that's 3 point extra can use to make up something else, right? So that's a good deal. It's equivalent to raise your grade to a level, to next level. Yeah, raise your grade from for example, from a B+ to an A-, or from a C- to a C. It's 3 points is a big deal, right? So try your best to get this bonus point out of the final, All right. And any other questions? Of the final? All right. All right, 3 questions comes. One is, may you go over the relay question in homework number 3? Yes, homework number 3. If you have your homework number 3, there's a figure, right? It's a figure. The figure is the figure I just showed momentarily ago. It's a relay, right? You try to deploy different relay at different locations, right? The homework number 3 asks you, why? Why? And the answer should be, see, the answer, the key is 1/n, n is number of hops. N is number of hops. That's the key point we're looking for in the homework 3 relay question. All right, and second question I see is, what was the percentage of question number 1, 2? Percentage of question number 1, 15% for true or false, and you have 15 true or false questions. So these 15 questions come from everywhere. Make sure you read the slides, and yeah, go over those content we discussed very broadly. That's a true or false. And the rest from question 2, 5%. Question 3, 15%. 4, 15%. 5, 15%. Oh, sorry, 5, 10%. 6, 15%. 7, 25%. That's all 100%, right? And let's see, 15% question number 1, 5% question number 2, 15% question number 3, 15% question number 4, 10% question number 5, 15% 6, 25% 7. That's 100%. All right, and 10% as a bonus, as a last question. All right. Third question, what about the project if we cannot finish? Is that okay? The project is as a COVID-19 outbreak. it impacts a lot of things, including our project. In fact, it's very normal. We make arrangement and we cannot finish whatever we promised. Yeah, it's okay. It's okay if you have you don't complete everything you promise in the homework in the project. But at least you need to make the presentation. See, if this is what we did, at least partially is finished. And you should come up with a conclusion. The conclusion say we did that, we didn't do that because of blah, 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 blah. And well, we believe this is achievable, doable if we have some resources or we have more times or some conclusions based on what you did. Well, you can take, yeah, you can come up with a presentation to present a partially finished project. All right, other questions? We don't have too much time, but we still have 10 minutes. This is going to be the last moment we're gonna discuss the exam preparation, the final project. Otherwise, next Monday, the first 6 groups gonna start presenting their project. Make sure you prepare the slides accordingly, and yeah, one of you guys can share the slides. Or actually, enable the multiple people can share a screen simultaneously. So, yeah. Any other questions? All right. So make sure next Monday, next Monday, the final exam time. Mark the time on the calendar. Right. Mark the time on the calendar. So I would like to ask you, how about the Monday? See, our exam is from 1 to 3, I believe. And does anyone has an exam after our exam? Let's see. Does anyone have an exam starting from 3 o'clock sharp? Yes, before and after. Okay. Some people have 3 exams per day. Oh, good luck. Good luck. All right. So all right. So yeah, that's why I have 2 hours, right? 2 hours of the the final exam. I don't want to impact your next exam, right? So 2 hours is it's enough, right? 2 hours is barely enough, right? Barely enough. All right, and some people see why is 1 over n. So based on the numbers, you can summarize this 1 over n. The reason is each relay introduces actual latency. Assume that all the relays are the same, right? And the latency, amount of latency increase is the same as well. So one hop with no relay is a baseline. 2 hops, well, there are 2 devices. Yeah, 2 devices. You introduce actual latencies. 3 hops, you double the latencies, right? So the more relays you have, the number of amount of latencies increase linearly. So one more relay you introduce, one more latency, one more amount of latency, period of time you're going to introduce as a latency. All right. So yeah, there are a number of people. Yeah, for those people who have a 3 o'clock exam, right? So you have to finish our exam by 3 and upload it. So yeah, that's arrangement issues for the at the university level. But yeah, so let's stick with 2 hours. Right? Don't go beyond 2 hours. And yeah, and I'm telling you honestly, the exam is very basic. The final exam is we emphasize on the basics. It's not super hard. It's not hard at all. But it's a very basic requirement. The basic requirement in the same level of the homework. Right? But you won't have too much time to, yeah. You have to spend your time wisely during the exam, right? Wisely during the exam. All right. Any other questions? are you going to hold office hours next week? Office hour? Yes, next week is the last. Yeah, still, yeah, I'm still hosting office hours next week. No, in fact, next week, yes, yeah, next week still, yeah. Okay. What else? Is this course graded on any kind of curve? All right. I'll tell you what happens last semester. What I did last semester was giving the bonus in the final exam the same way as I did this semester. I believe I curved moderately, a few, yeah, moderately. Yeah, a little bit, but not very significant, because you see the average of the class is doing fine. We don't have a huge curve. But yeah, a little bit. Yeah, see, for example, if you are so close to from a C minus to C, yes, it's sealed up. That's kind of a curve, a moderate curve, but not a huge curve. That happens after the final exam. Any other questions? All right. No more questions. Well, remember next week office hours still you can drop by, yeah, next week we still have class as presentation, right? And after all the presentation, if you have questions, you can still ask me questions in the class period. It's all the office hours. All right. Good. All right. No other questions. Okay. All right. I'll see you next Monday. And expect for group 1, 2, 3, 4, 5, 6. Prepare the presentation slides accordingly, and try your best to get the video at least from one person. All right. Okay. Take care. Bye bye.